Guys, I hope you're doing absolutely amazing so far. In this video, we'll talk about the layouts and constraints, which basically brings us to starting off with stacks, understanding VStack, HStack, which is vertical horizontal stack, and also ZStack. They are pretty straightforward to look at, and we'll talk about alignment and spacing as well. Right after that, we'll talk about a main concept called as safe area. And safe area is actually a part of your screen which is occupied by system elements. For example, on the top of your iPhone, you see a notch, you see a status bar, and in the bottom, you have the home indicator. These are basically the system UI components, and they are mandatory, they are always there. And that is the top and the bottom area for them is reserved. So, safe area, why we call it safe area? And is it safe for us to put our content on that? And if top and the bottom, that is where the notch is a safe area, then what do we call the area in between where we write our own UI components, right? So there are a lot of questions, and we'll understand safe area very much in deep. We'll talk about the safe area, how to selectively ignore the safe area as well. We'll understand finally something really more important, that is geometry. Now, geometry is a concept that is very important and it is highly used in production level application. Whenever you write any application and you're planning it to publish it on App Store, then it is really mandatory that you use geometry if your application support both portrait and landscape mode. Because when it comes to portrait, you are building your application, but the moment you want your application to be supported in landscape mode as well, then the dimension is where the problems comes into the picture. The dimension that you have for a particular card of, let's say, a carousel you have on the home screen, the carousel card size will differ in the portrait and the landscape mode, right? And we cannot hard code the size because we have many devices, iPad, a different size screen size iPhones, and we have to have in use of geometry there. And it's very easy to use, it's very helpful, and takes a toll on the hardware of the user device, but and that is where we do not overuse it. But it doesn't mean we don't use it at all and avoid the risks. It's kind of mandatory if you're trying to build a production level application. And right after that, we'll talk about scroll view as well. We'll just actually talk about scroll view a little bit right in the beginning when we are talking about stacks, and we'll see a real world use case of geometry. So let's get started. So I have mentioned here layout and constraints. We'll talk about stacks, that is V, H, and Z stack. Vertical, horizontal, and Z axis stacking. How we do that, we'll see that, and how we can align the contents of the stack. Let's start with this. So here I have the layout and constraint, the main view, and that is what we are seeing in the preview as well. So we are getting error because we don't have any view. Let's enable our sub view stack view example, which is right here. So what we will do is we will just create a separate structure for our concepts to learn, and we are just loading that particular structure or view. And this is a structure we are loading in our preview here. So let's talk about stack view, and I'll make it even bigger. So this is our stack view, and all we have the body in it, and inside that we have the VStack, some modifiers on it, HStack and ZStack. And we'll talk about alignment and spacing after that. Very straightforward, easy to understand. It just looks like it's a lot of code, but I will comment all the code, and we will start off just with vertical stack. We have three text. We want them to appear one below another. That's why we need a vertical stack. It's like you are vertically putting these views, and Bottom one will be this one, right above that it will be this one, and above that will be this one. And that's how it's appearing, right? We have given it some modifiers, and I will remove that so that we can just focus on our VStack. Now, our VStack, how much is the area? We cannot see that. It just, there are text. So if we provide a background color to our VStack, we'll be able to see. So we have this modifier here. Let's enable it. So we have the background modifier and we are giving it a gray color. And let's just put gray color like this. And this is our VStack having 3 views in it. Very straightforward. You want to give any spacing to your content which is inside stack view. All you have to do is to say spacing, and here you can say, let's say 10. And content, we have already given the content, so I will remove the second parameter and this comma, and I will see there is some space between our views. We can also give alignment. Let's talk about that in some time. First, we will give it a frame. So in the frame, we are giving maximum width. Here we are giving infinite, so it's just taking maximum width. And the frame alignment is leading. Let me just remove it. Right now, we are just giving a frame and the width is infinite. If we give here, our VStack will contain the views aligned. Alignment comes before the spacing. Dot leading, then all of our views will appear in the leading. That means our view will actually start in the leading position. Now our frame is actually infinite, but our VStack is not. So if we remove it, you will see our stack is this much only. If I give our stack background color and a color for our frame, you will see the difference. So we are giving a background color dot orange. This is how much our stack is. And then when we give a frame to it, and then we give the color, you will see the frame is having the width so much, but our stack is only this much with the orange color in the background. So this was just to give you a quick heads up onto when you are applying modifiers on VStack, you have to be sure when it comes to frame. And frame is not really just the container. VStack is a container and frame is just you are framing that VStack. Now, if we want to give some sort of spacing around our content, we can give it a padding. So I will say padding and I will give it 10. Now our item looks with padding. So the padding is around the VStack and it is on the all the 4 side. If I just say dot top, it will give padding only on the top, and all the 3 sides is very near to our items. So I will say all at the moment and I will remove this padding. So you can see what we can do with vertical stack. Although it is having the items in the leading or say near the left edge, but it's not having enough space to show that. So let's put a frame here with width size 100. Let's not put any alignment to it. And if we give the background to our stack, you will see it's still this, and the stack is not going to get any wider, because if let's say, because stack is something which adapts itself according to the content. If let's say your item is having less character, one only, you can see it is aligned in the leading. If we make it dot center, then the one will appear in the center. And you can do it trailing, so your content will appear starting from the right edge. And that's how you can align the contents. But the frame is not very much in use right now. It's not very useful when it comes to you dealing with aligning things, because VStack in itself is a very flexible container. So I will remove the frame, I will keep the padding, and I will keep the color as well so that we can see the padding. That is VStack. And let's talk about HStack. So when you want your content to appear horizontally, then I will actually comment our VStack, and our image and text image is a star fill image which looks like this, and we have the simple text SwiftUI. Right now we have written the code right after each other, so it it is just components. But if you want them to appear in horizontal way, in a horizontal stack, that's when we use stack. And it goes same as vertical, it's just that it has the alignment or keeping or positioning the UI elements in a horizontal manner. And that is it. I will move on to the next one, that is ZStack. And ZStack is really like a layer on your screen. So in the ZStack, we have rectangle, which is filled with blue color and also has a frame. We have simple text saying overlay and foreground color white, and the font is title. Now these are the two components. If you use VStack, it will appear right after another. Since it's a white color, we are not able to see overlay, so let's make it black. So we can see the two UI components are appearing right after another because it's a vertical stack. If it was a horizontal stack, it will appear like this, but because it's a Z stack, it will overlap. It will come, the first one will come, and in the Z axis, in the 3D, the third axis, it will put the text right above the rectangle. And that's it. I will comment this, and let's talk about a bit on alignment, which we already have discussed, although. And if you have less characters, we have seen it, then you are able to see if the alignment is working or not. Since it's trailing, it will start from the right edge. And this spacing will be kept vertically and only vertically. This is the frame. Let's remove it. And you can see the spacing will be applied vertically only. There is no spacing left and right. And after the last text also, there is no spacing. It's just in between the components, they will maintain spacing. Suppose you have multiple text and you want only a space after the three texts, because right now it is giving the space 20 after every component. So in that case, it's not helpful, so we'll remove it. And here we can use space. It will push the above three elements and below as much as possible, as much as the area is there on the screen to occupy. But if you use minimum length, then it will maintain at least of 10. Right now it has more than 10. To make it only push a little bit, there should be some content above and below. If you give it width fixed and height fixed, then it will push, the spacer will push the above content as much as possible. Since the VStack has the height fixed 200, it cannot push it any further, but it will occupy as much as it can get. That was ZStack. Well, this is VStack and the alignment and spacing in the VStack. And that is all. I will uncomment this, all of it, actually from here, and we can keep it as reference. Right now I will just comment this, and now we will talk about safe area. And for that we have our second view. So this was our stack, and let's understand precise safe area. The way I've named it is precise because we're going to exactly look how much is the area on our screen is the safe area. I'm going to zoom out, and here we have a lot of code. I'm going to comment most of it, and we are going to keep the simple this much. So we are using geometry reader here. What is geometry? I'll give you a quick brief. It is basically something that gives us access to the dimension of your screen. It gives you access to the safe area as well, and what all things we can access, we'll talk about that. But what we need to do is right now we have a Z stack. It's just a layer, and we are filling that layer with a green color with an opacity 0.3, so it looks a bit lighter. And that's it. Right now you can see the layer, the Z stack, having the color is not taking the whole screen. It is leaving some space above and below. That is because that area is called safe area. But wait, that is not the only area which is called safe area. There is a bit more here which is also called safe area. We'll see why we have the two safe area here. So first of all, what is safe area? So when we see this notch, and let's run a simulator, actually I have it open. When we talk about the time, notch, Wi-Fi and battery, this is our status. And because these are system elements, whether we can write it or not is something we'll take a look further after some time. But right now, these are components or system UI components, and the area is kept safe only for that. So we understand that this is time notch and this is a safe area. Bottom, you will see some safe area here. That is because when you open any application, you will see this line here. So this is a home indicator, which we use to switch applications. And this is the home indicator right now, which is occupying this much space. And this is the safe area occupied for that only. You can see if we keep it together, you will be able to see this line. If you further extend it, the summary, fitness, and share, these tabs are starting right after where our color line is starting, where our color is starting, or to be specific. And this is the safe area. Here on the top, if you will see, this is the line which is kept for the notch and basically our status bar. And this line, if you extend it, you can see it just keeps this much area for the status bar. Now let's talk about that second part of our top safe area. What does it really specify? So what I'm going to do, well, just before that, let's talk about one modifier, that is edges ignoring safe area. If you want your color to really ignore the safe area and just go beyond that, we can use it. And now your color will actually fill up the layer, the Z stack completely. And we can specify what all edges or what all area, safe area you want to penetrate the color. The color will penetrate only top if you mention top here. And you would see the bottom is safe area is not penetrated by our color green. And this is where we can give bottom as well, just giving bottom, so the our top safe area will not be penetrated by green color. And let's comment this right now, and let's talk about the second safe area, which is somewhere here I was talking about, right? So what I'm going to do is create a VStack, just some UI component with a spacer in it. And what I'm going to do is use a modifier called safe area inset. What it means is this is the modifier that we use when we want to place some components, our components, not UI components, our own components like text or color like that. We want to put it inside the safe area. Now we just learned that the safe area is this one. So why are we putting red color UI component of our own inside this here? It should have been here, right? Well, this area is also considered as safe area. Why is that? Because this is also the safe area, but for UI components like navigation bar. When you create navigation bar, you must have noticed a back button. You can see this is the title. Maybe let's open another application where we can get a navigation bar. This is the contact application. We have this back button here, right? The plus. This is part of the navigation bar. When you click on back, you will get in the navigation list as well, the title of the navigation. Here the edit and the add list is actually the buttons of the navigation bar. Now we most of the time we have something going on in the top area. We are using navigation bar, and just like that we have some area in the bottom for our tab bar. That is, let's open this application fitness. You see tabs, fitness and sharing here, and summary. It is taking somewhat of space below, right? So we understand the safe area right here with the white space here and here. We understand this is for the notch and basically for our status bar, and below is for home indicator. But the area that is generally most of the time occupied by tab bars like this and by navigation bar like this is also considered safe area. If I put this here, you can see this red is what I am putting inside that top safe area. So you can see this is till here. If you extend this line, it will cover this title as well, which is falling halfway inside the safe area and half outside the safe area, which basically comes or brings us to the point that we can place our things as well, our components as well inside the safe area, like normal components other than navigation bar. So we understand why this region is also called safe area and why the below one as well. So let's load the below one as well. And here this much is the area for our tabs. If we open our fitness, and I will put this along this, and you can see this much is the area for our tabs. Right now, our tabs, if we go on summary, we can see that our tabs are starting out here, which is our own area, and the safe area is ending somewhere here. So it is possible that we can, whatever component we are writing here, it can penetrate to this safe area where our other components goes, like tabs and navigation bar in here. And there must be a question that arises here, that is, why do we have this much? Why can't we have till here? Well, how do we measure this? Well, when it comes to geometry, as we spoke earlier, it gives access to the dimension, the safe area. Here we take advantage of that. So what I did is we have the VStack, and dot safe area inset is for inserting your UI components inside the safe area. All we have to mention which safe area you want to put your UI elements inside. We have to mention top, that means the top edge. And what we are doing here is just filling it with color and giving a frame with a height. The height is where we are giving a numeric value which we are getting from the geometry. The geometry dot safe area and set dot top gives you the top safe area distance in point. Distance, by that I mean distance of these this red rectangle from here till here. And that is what we are using as a height for our frame for our red color. And that's how we can actually display completely exactly how much on the top the safe area is. We are putting our UI element red color. We can do anything else. We can put a text, things like that. And the question arises, if there is a navigation bar on the top, won't it impact the UI? Well, that's where we push our brains, use this not for just displaying like this, but also for padding and things like that. And we'll talk about that, how to actually not let our UI components with the navigation bar here overlap. And but that's a whole separate thing, how we can utilize geometry to place our contents in this safe area or this safe area as well. We'll talk about that later. For now, we're just understanding how much is the safe area. And in the below, you can see I'm doing the same thing, dot safe area and set. We're in setting or putting something, our UI element in the safe area. And the bottom safe area is what we're talking about here. So we're again putting the red color with the frame of the height. That is what you're getting from the bottom parameter. It's a property that gives you the distance of the safe area from its upper edge and lower edge here. And that's it. That is how we use geometry to showcase. Right now we are in the code, we are just showcasing how much it is on the top and the bottom. Well, what about left and right? Is there any safe area there? Not at all. It's absolutely zero. Our content goes edge to edge when it comes to left and right, or leading and trailing edge. There's no safe area here. Now this safe area, the right now, if you talk about this one, which is distance, or you can say height of the red rectangle, this is different in different devices of with different screen. So let's say it is 16 Pro, then this could be a bit different, and this could be a bit different in the sense right now it's compared to 16 Pro and 16 Pro Max. There is a possibility, let's say we have iPad, then this top and bottom safe area may vary in size. So I have written here some notes. So Geometry Reader ensures that carousel dynamically adjusts in both portrait and landscape mode. So carousel is just an example. This is the real world use case, which we will see near the end of the video. If there is any UI element we want to display, and we want to, we are creating this application, we are displaying carousel, let's say, we're keeping the portrait mode in mind, but we want our application to support the landscape mode as well. Well, when you see the carousel in landscape mode, everything changes, right? The dimension of the carousel, the cards in the carousel will change. In the sense, it will not change, it will stay same, but it should actually change. It should scale up a little bit because now it's a different mode. And that is where we don't know which, because we have different iPhone with different screen size, and we have iPad, so we don't know exactly in the portrait, in the landscape mode, how much the scaling up of the carousel card should have done, we should do. So we cannot give any hard coded values to our frame of the card. That's where we take advantage of geometry, which helps us in getting access to the screen size safe area, so that we can keep our components in the safe area, outside the safe area, our choice, and keep our carousel working, supported in both the modes. Because in the portrait it will have different width and length, width and height of the device, and in the landscape the height and length of the device screen will be different, and according to that our cards of the carousel will adapt. And I've written here it provides rotation, scaling, adaptive positioning for a smooth user experience. These are just the three parameters. Rotating and scaling are the two just parameters where we can use geometry. With the help of geometry, we can gain access to the size of the screen and just calculate things a little bit, how much you want to scale up the cards, right? We'll talk about this more into when we are talking about the real world example, carousel. So let's just get things clear here. When we talk about safe area inset, safe area inset is a SwiftUI modifier that lets you add content inside the safe area without affecting the main layout. It ensures that your custom UI elements like toolbar, button, overlays appear inside the safe area without overlapping system elements. Here it's talking about system elements like navigation bar for this safe area, or notch, or time. And here I've mentioned the notch, also known as dynamic island, and the home indicator, which is right below here, status bar, which is the top one, and the navigation bar, which is this one. So just to give you image to remember, this one with the battery sign, Wi-Fi, and the notch. This one is the status bar. It has 59 points. That is the height. And this is something that varies when it comes to iPad or different screen size iPhones. This is the navigation bar, which is 102 points height. We have the page and we have tab bar here, or say action bar, which we have seen in our sports application. This one here we have this summary, fitness, sharing, and this much has 50 points. So I have somewhere mentioned here the approximate safe area inset across iPhones. So here I have mentioned the devices, the top safe area, and the bottom safe area. So when we talk about portrait modes, which is this way, 14 Pro Max, it's 59 points top safe area, and 34 bottom safe area, which is this one. And Pro, the top area is still same as the Max, but when it comes to 13 and 12, not Pro Max, normal 13 or normal iPhone 12, it's 47. So for smaller iPhone screen size, the top safe area gets reduced. If you talk about SE, no notch, then it's 0 points. So here we have the status bar, and this is our safe area. Right now, when we talk about the top safe area, 59 points, it is actually talking about the status bar and not this one at the moment. But let's come back to our notes and let's take a look at our one question here. When should you use safe area inset versus edges ignoring safe area? So when we want to place contents inside safe area, we go with safe area inset. But if you have a color to extend and penetrate to the safe area, we use the edges ignoring safe area. So I have scenarios here and when to use the safe area inset and when to use edges ignoring safe. So if you have a scenario like want to add a toolbar inside the safe area, then you go with the safe area inset and not edges ignoring safe area. You want to extend a background image video to full screen, go with edges ignoring safe area. So for color, for image, for video, you can just ignore the safe area, let it scale or fit by the screen size. So we can apply the modifier as well, fit, scale to fit or scale to fill, like that. If you have a scenario where you need a floating button, navigation bar, so somewhere here you need a button, then you go with safe area instead because you have to place that button inside the safe area. And we do not use the edges ignoring safe area there. So the final thoughts on it is the safe area inset allows placing content inside the safe area without affecting the layout. Prevents overlapping system UI like notch, home bar, status bar. Useful for floating buttons, toolbars, and custom overlays. We have not seen toolbars, what is it, but we know buttons. Just imagine a button placed here. So just like that, toolbar is another component of ours which we can put a custom overlay. We talked about overlays. You can just keep a view overlaid on top of the safe area. And that is why we use safe area inset. Let's talk about the property here, which we have used to get the height of the top safe area or height of the bottom safe area. What is exactly this is? So what is the property top in SwiftUI? Geometry.SafeAreaInside.top is a property inside GeometryReader that tells you how much space is occupied by the top safe area, status bar, notch, or navigation bar. So right now, let's access how much the height it is actually returning. And that is where we have written a simple program for it. We'll come to this, but let's take a read on this. This value dynamically changes based on the device, 14 Pro, iPad, etc. Screen orientation also matters, portrait or landscape, and whether a navigation bar is present or not. And that's where we already saw different iPhone size has different top safe area and different bottom safe area. Now it says 59 points, right? So to take a look at this property value, all we are doing is just printing it in the text. So for top, it's dot top. For bottom, it's bottom, and left leading and right trailing. Specify here is having this percentage dot 2f. It basically means the value it will return. We want the decimal value up to two digits. And that is it. We have a vertical stack to represent our text, and we are putting this all in the geometry. We have two modifiers for our VStack, padding a little bit, and a background color. So this is just to make it appear correctly, just so that we can read it. Let's load this view all safe area values. I will put this in our, I will comment this one and all safe area values. It will load here. Now let's go back to our code. And here the top one returns 62 points. And we can see the leading and trailing here is 0. We do not have any safe space on the left edge or the right edge. Why use geometry safe area inside dot top? Well, if you want to prevent content from going behind the status bar, you can adjust that. If you need to place a custom toolbar or header below the notch, you can use it for that as well. Want to detect the top safe area size for debugging purpose, which we just did here. These are some of the use case. Although we will take a look at the real world example in some time. So let's move forward to our real world example. Here we have a carousel. I will actually copy this and load our, I will comment this, and this is our responsive carousel view. Let's go to that, and here we have the responsive carousel view. Right now, if I scroll, you can see it's getting scrolled. So how the scrolling is happening, let me just give you a quick go through on what is. I will comment our responsive view and we'll load a stack view example, which is this view. And here on the top, I will mention some text. I will just copy this, or I will copy the image, and I am going to actually keep a lot many images here, and I can use scroll view on it, and you can see this is the scroll view, and I can give it some frame. and I can just give it to all of images. Let's wait, and you can scroll it to see through. This is the indicator which comes by default. If you want to turn it off, that is also an option, but this is how the scrolling works. If you want to make the horizontal scrolling, we have some option here. Dot horizontal. Whether you want to show that indicator or not, let's keep it false, and we have already returned the content. And let's make this HStack so that it is going to appear horizontally like this, and we can scroll over it horizontally as well. So you can see like this. Let's give more images here, and you can see we can scroll through it. Right now we are not able to see indicators, so if we turn it on by setting the value to true, and let's wait, and if you scroll now, you can see the indicator here showcasing where you are while scrolling. That is how scroll view is. Just a short brief, and now we can come back to our example, that is the responsive. So let's go to our responsive cursor view, and here what we have, let's take a quick walkthrough on the application. And just this code is there showcasing a carousel. So let's first run this application and see. Since it's using geometry, we have written a code in a way that it will work very well in both the modes, in a portrait and landscape mode. And right after here we will see the same examples carousel, but without using geometry, how that appears in those two modes. So let's run our application. Let's wait. And now it's loaded. The moment you switch to the landscape, the size will scale up. And that is where we take advantage of the geometry. We gain access to the length of the screen and height of the screen and make our card adapt to that particular mode. And you can see it's all working very good. But let's see now one another example. This is our portrait mode. So we will come and take a look at this, but let's take a brief look right now. We have this geometry reader. We are putting everything inside the geometry reader. We have the scroll view, which which allows us to scroll on the content of it horizontally. We are keeping the indicator false. We are not saying it. And we have our horizontal stack, inside which we are running a for loop, and we are going through our images. We are taking the images one by one. This asset image is right here in our asset, and we are just going through it. I'll refresh it, and here we are just running through each image, and in here we have written code for displaying the image. Now you will see a geometry reader once again here, and we are accessing the frame, the global frame, and taking the min x coordinate, and where that coordinate is, based on that we are calculating a lot of things for our image. So till here it's all our image and their modifier. For each loop takes one image and creates the image. After that image, we are just giving the image this much width and this much height. So we are ensuring the correct scaling here, and the image also should scale according to the frame, right? So we are having the frame here, which is also having the width 60% and height 60%. We have two new modifiers here to learn about. We know resize, scale to fit, and the frame here. Corner radius is also when you want to clip the corner radius a little bit, that's when you do it. Uh, the rotation and scale effect are the two new. We know what is shadow as well. Let's take a look at rotation and scale as well quickly. Rotation effect, we just have to maintain rotation 3D effect actually. Have to give the degree by how much you want to rotate. So if you see we are scrolling, it's sort of a rotation, 3D rotation that you can see happening. And the scale effect is also, there are some calculation based on the global frame, and that is where we are doing scaling and a rotation in 3D. So here the rotation 3D effect adjusts the rotation dynamically, and we are dynamically scaling here, and that is all. Pretty easy, very straightforward, right? Now let's take a look at the notes. Why we use geometry to make the UI better. So problem without the geometry reader, if you were not using the geometry reader, the static carousel that looks bad in the landscape mode. Right now it's looking like this. If we are not using geometry, then it would have been looked exactly like this in our landscape mode, which according to the landscape mode, the image size would have been very small. The image do not rotate when scrolling. So we have seen the scroll view, it just scrolls. But if you'd like some 3D rotation and scaling for that, you need some number by which you want to scale it up, how much you want the rotation, right? So that would have been very static numbers and not good for, maybe good for this device, but not for other devices with different screen size and iPad especially. So images stays the same size even when centered, no smooth UI transition when scrolling, and geometry readers gives us a solution. Screen geometry.size.width adapt to the both portrait and landscape. The 3D effect makes images rotate dynamically. The scale effect makes the center images larger and the edges smaller. Geometry reader tackles scroll position and applies animation. When there is no geometry, it's a simple scroll view with horizontal stack having the images, some modifier on the images, having the fixed width and height. Let's see this action where we do not have it. So I'm going to just change the name for it, and let's load this one. After the responsive view, this is a simple carousel view. So this is our scroll view at the moment. There is no rotation or scaling. Let's run this. So it's a portrait mode. It all looks good. The moment you move it, this the size of the image is still same. There is no scaling up. It's, you can see that if it would have taken some more space, maybe this much and this much, it would have looked better, and we would not have this extra space, just free extra space. So since we have the room, we would like it to scale it up, and that's where we need some dimension, how much percentage of the image you want to scale up. And the calculation is something that we do, that is something which we can always look for based on the different screen sizes we have, and that's all. This is the problem, and geometry resolves that problem very efficiently. Since in the beginning of the video we talked about why geometry, learning geometry is very necessary, is because whenever we have any production level application, almost every business application has carousels in it. We have to have, if the production application, the enterprise level applications supports both the modes, landscape and portrait, you have to have geometry in place to adapt, to make the view adaptable for both the modes. And that's it. Let's take a read on one node I have. So the problems you will face without geometry reader: there is no adaptive UI in landscape mode, no dynamic scaling, no 3D rotations, no smooth UI feel. This is what happens in case of no adaptive UI. The images are fixed size, so they don't resize properly. when the device rotates. Geometry helps you scale dynamically based on the geometry screen. That is the parameter here, screen geometry.size we used in our example. There is no dynamic scaling, so every image stays the same size, even in the center of the screen. Dot scale effect makes the center image large, improved focus is there. When you have the scaled up image, it's better to take a look at the details of the image. In the landscape mode, since the landscape provides a bit more luxury, more space for work corrosion. There is no 3D rotation, so images look flat and static while scrolling. Since we have only the scroll view, no 3D rotations we applied. For that, we need static or dynamic numbers, and geometry provides dynamic numbers. So the geometry makes our 3D scrolling effect visually appealing, and no smooth UI feel is there, so scroll effect feels basic like a simple scroll view. Geometry to make scrolling more interactive and immersive. So the final key takeaway is this simple carousel works, but it lacks smooth effect scaling. The simple carousel we are talking about where we are not using the geometry. Without geometry reader, your UI is less adaptive, especially in landscape mode. And that is all. If you go on the top, we have seen the geometry real world example. We talked about scroll view, vertical, horizontal scrolling. We talked about the safe area, ignoring the safe area, and a lot of about geometry and how to make our code layout responsive. We talked about the stacks as well. I hope you find this video informative, and I will connect with you in the next one.